Hi, so in this video I have some extra material I want to cover that is also going to help you with the weeks to come and also with this week as well, which is week 4. So the extra material I'll be talking about in this lecture video is regarding multiple inclusions of header file and abstract class. Both topics are mentioned or talked about at least, I think, starting in week 4. So what does multiple inclusion of a header file mean? Well, when you're dealing with inheritance or composition, which is what is being talked about starting week 4, you do end up sometimes with multiple inclusion of a single header file in a project. For example, let's say you have a student class. Well, if you have a student class, then you probably have a student.cpp file that has the implementation of all of the function definitions. Well, so in your student.cpp file, you're going to end up including a student.h above the student CPP file. But then let's say you also have a main CPP file where you have your int main, and you're going to be creating student objects. Okay? That means you will also have a number include student.h in your main.cpp file. But let's say in this exact same project, you also have inheritance, okay, where you have one class inheriting from the student class. Well, that means you have yet another CPP file that's going to have a number include student.h above that. So here you'll notice we have a multiple inclusion of a header file where in one single project, we have number include student.h in several places. So we have number include student.h in student CPP, we have number include student.h in main CPP, and yet another CPP file if we're doing inheritance, and also again including numbers include student.h. So that basically means we have the one single header file being included in multiple places in the same project. That's what multiple inclusion of a header file means. Okay, so that is 3 number include student.h in one project. So what does that mean? What does that do? This can actually cause the computer confusion, and your program might work and all of your code might be fine, meaning there are no syntax errors, you know there are no syntax errors, but when you hit compile on that project, you're actually going to end up with linker errors because the computer is very confused. You have the same header file included in several places in the same project. It will cause you errors even though, let's say, your code has no actual syntax errors. So how do we fix that? What do? How can we solve this? All you need to do is when you're creating your class in your header file, .h file, you need to add these lines of code. If in def, the capital H underscore, and then the name of your header file. Number define, capital H underscore, and the name of your header file. And at the end of your header file, you need to add number and if. What do these words mean? The if in def basically means if not defined, and then H, whatever your file name is. And then the number defined means then define your file name.h. And then of course end if means end the if statement. So what this does is just prevents the computer from confusion. So if a computer, in your project on the computer, you are including, in our case from the previous slide, you're including student.h 3 different times in the same project, by adding this code to your student.h file, you're basically saying, okay computer, when you're compiling my code, only if student.h has not been defined yet, then define it. Otherwise, or with end if, otherwise don't define it anymore. So what that does is the very first time the computer comes across number include of student.h, it includes it. And after that, it no longer has to include it. Even though number include student.h is in 3 separate places, it only includes it once, and therefore all of that linker errors will be gone. So that's all you need to do is add these 3 lines of code every time you create a class header file. So here's how it looks like in syntax. So here's my student.h. This is what we've been used to. So every time we're writing a class, this is how we've been writing it in the header file. We've been writing it as class, the name of our class, so in this case student, open brace, close brace, semicolon, and then all the stuff in between, which goes under the public or the private headers. Now all you need to do to prevent confusion when it comes to multiple inclusion of a header file in a project is just add these 2 lines right above your class keyword and this is class name, and then to add this right here at the bottom after your brace, close brace, and semicolon. So basically what you're saying here is if student.h has not already been included yet, then include it and if. That way, if you do have one project where you have student.h being included in 3 separate or 4 separate or 5 separate places, the computer, when it's compiling, will not be confused because of this if statement you have on there. It will include it once, it will know that it's included, and there will no longer be a linker error. So if you find yourself when you're dealing with multiple file projects, especially now that we're getting into inheritance and composition, which you can end up with one project having 6, 7, 8 different files in the same project, you are going to have multiple inclusion of the same header file. So this is a time where every time you create a header file, please include these 2 lines above your class interface and then this line at the end of the class interface. That way you prevent any linker errors from happening when you have multiple inclusions of the same header file in one project. So in this case, going back to our example, if I have a number includes student.h in student CPP, if I have a number includes student.h in main CPP, and yet another CPP file with number includes student.h, where I have 3 separate number includes student.h in one project, it will not be a problem because I added this if above and below, this end if below my student.h file when I was creating my class student. Okay, so all you need is this and this. Make sure to include that in your header files from now on in your projects so that anytime where you have this issue, you will not have any linker errors. Alright, so that was the multiple inclusion of a header file topic I want to talk about in my extra lecture here. My other topic is abstract class. The reason why I want to cover abstract class is because you do have an abstract class you have to create, I believe, this week for week 4. So I wanted to cover that because it's going to come up later as well. What is an abstract class? An abstract class is basically a class that contains one or more pure virtual functions. So just by containing just one pure virtual function, an abstract class is already an abstract class. But if it has more, so one or more pure virtual functions, then a class is considered an abstract class. So once again, a class is considered an abstract class as soon as it contains one or more pure virtual functions. Okay? So what are pure virtual functions? A pure virtual function is basically a function that looks like this. So here you're usually used to having a function called void draw. But if you put the keyword virtual in front of it and then an equal to 0 at the end of it, you have now made a pure virtual function. Okay? So what is a pure virtual function? It's just an abstract function. What it means is this function has no definition. So you're kind of just setting a placeholder of a function, but no definition. So that's a pure virtual function, a function with no definition. Okay? So when a class, so here we have a class called shape, that has 1, 2, so remember just having 1 is enough, but this class has 2 virtual or pure virtual functions. So automatically what this does is this makes class shape an abstract class. So class shape in this case is an abstract class because it has 2 pure virtual functions. And the pure virtual function, once again, is just a function which has a keyword virtual in front of it in the function prototype and equal to 0 at the end of it. Do not forget the equal to 0. Just because you put a keyword virtual in front of it does not make it a pure virtual function. You have to have that equal to 0 at the end. This is what makes it a pure virtual function. So when the class has a pure virtual function, which basically means a function with no definition, that class is an abstract class. So why do we even have this? Why do we even have an abstract class? What's the point? Well, let's say you're creating a class called shape. Chances are this is going to be a parent class because there's going to be more specific shapes to deal with later on. There's going to be circle, of course, rectangle, square, etc. So you know, when you are creating class, you're certain that it is eventually going to end up as a parent class. So you know there's going to be classes derived from this. You can actually set up an interface where you tell the person who will be inheriting from this class, yes, you're going to have a draw function and a move function, but I am not going to define them because shape is very general. Drawing a circle is going to be totally different from drawing a rectangle, which is different from drawing a square. Moving a circle is different from moving a rectangle, which is different from moving a square. So you realize as you're designing your class shape that you are designing a parent class, and you know that a shape needs to be drawn and moved, let's say, but you don't really necessarily want to define these because drawing a circle is different from a rectangle, different from a square, and so on for move as well. So you realize there's no point in defining these functions because you realize that different shapes will have different function definitions. So what you do is, as you're designing your parent class, you leave to the child class the interface of having a draw and a move function, but you don't leave a definition because you know that the child class will have to figure that out based on what specific shape it is. So that's what a virtual or pure virtual function is used for, and that's why we have abstract classes, usually used as interfaces. So we just kind of set up an interface for future classes to kind of pick up where we left off, if you will. Okay, so let's take a look at how this looks. So if you derive a rectangle class from the shape class and want to make it non-abstract, then the rectangle class will have to deal with those two pure virtual functions and define it itself. So an abstract class can contain more than just pure virtual functions. An abstract class can have constructors, it can have other non-virtual pure virtual functions, it can have variables, but as soon as it has just one pure virtual function, that class is referred to as an abstract class. Okay, so the abstract class does have to define any other function it has in there that's not a pure virtual function, but other than that, the pure virtual functions it does not have to define. So here's my example. Here I have a shape.h. Notice if you kind of look through the shape class, I have two functions in there that are pure virtual functions. So automatically we know that shape is an abstract class. So just having one pure virtual function makes the class abstract. So in this case, shape has two, so obviously class shape is abstract. Okay, but an abstract class does not have to only have pure virtual functions. It can have other types of functions, and it can also have variables. So notice in my class called shape, I have a variable called string name. I have a set name and get name functions that are not pure virtual functions. They're just regular functions. So yes, an abstract class can have other stuff in there besides the pure virtual functions that it also has. So let's take a look at what the shape.cpp would look like right here. Notice in shape.cpp, even though in my class shape header file I've listed 4 functions, in my CPP file I only have definitions to 2 functions, 2 out of those 4 functions. Why? Because these 2 functions are pure virtual functions. And remember, pure virtual functions are kind of like placeholders. You're basically saying, okay, whatever class inherits from me, go ahead and define it for yourself. I'm not going to define these. So in the shape CPP file, you'll notice we don't have a definition for draw, and we don't have a definition for move. We're kind of setting it up, telling the other classes that we're going to have draw and move, but you're going to have to define it yourself. So the pure virtual functions don't get definitions in shape.cpp. So the only functions that I'm defining in shape CPP is set name and get name, and all I'm doing are just mutator accessors. So in this case, set name just takes in a string and then sets it to the private member's name. Get name just returns name. So just because a class is abstract doesn't mean it cannot have other functions and variables like a normal class. It just means it's now an abstract class because it also contains one or more pure virtual functions. And the syntax for a pure virtual function, once again, is the keyword virtual in front and equal to 0 at the end of a typical function you would have. Okay? And in the function prototype. And you'll notice pure virtual functions do not get definitions in the CPP file. Only the regular functions get definitions. Okay? So shape is our abstract class. Right. So now let's look at rectangle. Here we have a rectangle class. In the rectangle class, you'll notice I didn't really complete it all together, but I just want to show you an example. So here we have a rectangle class that publicly inherits everything from the shape class. So it inherits publicly from the shape class. Okay? So what does the rectangle class now have to do? Because it inherits from the shape class, it needs to have a void draw function. It needs to have a void move function with double x, double y as the parameters based on what's written here. But unlike in the shape class, the rectangle function will have to take out the words virtual and the equal to zeros out of these two functions, because now is the time, because we're now specific, we're looking at a rectangle, we can draw it and we can move it specifically to that shape. So what the rectangle class now has to do when it inherits from the shape class is actually define draw and actually define move. So you'll notice here the rectangle CPP file will have the draw function definition. It will also have to define the move function and define it there. Obviously I didn't finish it, but just letting you know that the two classes that are pure virtual in the parent class, if rectangle class wants to be not an abstract class and inherits from an abstract class, it will have to take those placeholders that the shape class left and actually define them and give them, you know, tasks. So rectangle class will have to define draw and move. So because shape is an abstract class, you cannot have an object of class shape. So that's one thing that you need to really remember. As soon as your class becomes an abstract class, in int main, you cannot create an object of that class. So you can't say, okay, shape 1 or something like that in int main. So you're trying to create an object called 1 of class shape. You cannot do that because shape is an abstract class. So that's one thing you kind of sacrifice, is that as soon as a class becomes an abstract class, you cannot make an object of that class. However, in this case, rectangle is not an abstract class, so I will be able to make an object of rectangle in int main if I were to. So in this case, shape is the abstract class, rectangle is not, but rectangle is inheriting from the shape abstract class. In order to become not abstract, rectangle will have to define draw and move, which are the pure virtual functions in shape, and actually provide definitions for draw and move in the rectangle class. Okay, so once again, shape is abstract class here, rectangle is not. So those were the two topics I wanted to talk about for my extra lecture, multiple inclusions of header files and abstract class. Okay, thank you.